All right, this video is going to be pretty much the same thing, just with sine now, okay? So the proof, which we're not going to do, is pretty much the same idea as this proof. We're not going to do it. And the answer is very similar as well. So again, we can think of these as color-coded, plus and minus. And what we have here is that it's going to be very similar looking. The sine of the first angle times the cosine of the second. And now the sines will match. So instead of being opposite like in the first one, they'll be the same here. And now it'll be cosine of the first angle times the sine of the second angle. So in the cosine formula, the sines were different, but the trig were the same. Here, the trig is different in each pair, but the positive and negative are the same. So it's just kind of like a little mirroring a little bit. Okay, so that's the formula. That's what we're going to use. Let's do some problems. It's basically the same thing. So again, very good practice. If you want to just pause the video and do these on your own and make sure that you do them correctly. Also, we can actually say something really exciting. All right, we're going to take the opportunity to say something exciting. Remember this guy? We can now do it. Sine of something plus something else is sine cosine plus cosine sine. So this is sine of x, cosine of h, plus cosine of x, sine of h. We can now actually continue simplifying for this average rate of change. And it doesn't look great, but we're very close to something. We can factor out a sine of x from the first guy and the third guy. And that'll give us cosine of h minus 1. And then the second one is just cosine of x times sine of h. And why this is really, really useful is it eventually allows us to use some other thing in calculus called L'Hopital's rule, which we can use to then continue it on. So we only got one extra step in. We're actually still a little stuck, but don't worry. In calculus, you'll learn the next step and you'll eventually get to finish this problem. All right, but yeah, then we need some fancy limit rules after this. Okay, so anyway, let's move on with this actual section. Example 2, evaluate. Exactly. Part A. Let's look at the sine of 15 degrees. Oops. It's the same thing as the last video. Just practice with a new formula. So here we have a subtraction. It's the angle difference formula. So if we're using subtraction here, we use subtraction here. So it'll be sine of the first, cosine of the second, minus cosine of the first, sine of the second. All right, so sine of 45 degrees, cosine of 30 degrees, minus cosine of 45 degrees, sine of 30 degrees. And you just use your special triangles and simplify just like we did before. So 1 over root 2, root 3 over 2, minus 1 over root 2 times 1/2. We get root 3 over 2 root 2, minus 1 over 2 root 2, and we get a very similar answer to something we've seen before. And we could check our answer. But what are the chances that I made a mistake again? Yeah, it's a good habit to check your answer. Well, let's move on. Letter B. Let's get something a little bit more interesting. So the sine of inverse cosine, woo, let's have some fun, plus inverse sine of 3/5. Ah, it's like we're back in 8.3. Isn't that fun? We can't simplify the inside unless we approximate with a calculator. But if we want to find this exactly, that won't work. If we want to find this exactly 100% exact, no rounding anywhere, we're going to have to use the angle sum formula. And you might say, but Jason, we don't have an angle sum. Aha, but we do. Remember that sine takes in an angle and gives out a ratio. And inverse trig take in ratios and spit out angles. So this is just some angle. This is just some other angle. So we do have one angle plus another angle on the inside. We can use the angle sum formula. Wow, what a pleasant little surprise. So if we do that, remember the angle sum formula for sine means we're going to have a plus. Since we have a plus on the inside, it always matches. So it's sine of the first angle, cosine of the second angle, same sign, so plus plus, cosine of the first angle times the sine of the second angle. Gosh, this is confusing. So we got some great news and some other news. The great news is, look at this. We got inverse functions. They just undo each other. As long as we're in the right part of the domain anyway, which we are. So this second half is easy. That's just 1/2. Cancel, cancel. The second part is just, if I can read my own handwriting, cancel, cancel. They're inverse functions. They undo each other. All right, I did the second part. You do the first part now. Okay, we're going to need to be a little creative. Remember that this is some angle. Remember that this is some other angle. We're going to need a picture. So we're looking at what angle is the inverse cosine of 1/2. We're going to draw a triangle. Inverse cosine of 1/2 is going to look like this. Because inverse cosine of 1/2 is some angle, means that angle, the angle is the angle that has the cosine of that angle equal to 1/2. That's what inverse cosine of 1/2 is, that angle. Cosines adjacent over hypotenuse. We can use the Pythagorean theorem to get that last side. So what's the sine of that angle? That's what we needed. Sine of that angle is √3/2. Oh, actually, this part we could have done without the triangle, right? We do know the cosine of what angle is 1/2. The cosine of 60 degrees is 1/2. But anyway, it's good practice. We can draw a triangle for the second one as well. Sine being 3/5 means we have this triangle. Use the Pythagorean theorem to get to the x coordinates 4. So cosine of that is 4/5. So there we go. Let's combine everything. We get 4√3/10 plus 3/10. And now many of you will get really excited and say, oh, let's cancel. Let's reduce. We don't want to do that though, because we'd like to combine these fractions. They have the same denominator. So this is the best answer in my opinion. And this one doesn't simplify or cancel because you can only reduce if you have a common factor. So there we go. We can check our answer. That's it. So this is just extra practice. Again, at its heart, use the sine formulas the same way that you use the cosine formulas. But cosine, remember that whatever's on the inside and the outside are opposite signs, whereas sine, they always match. What's tangent? Well, you already know it. Tangent sine over cosine. But we'll save that for the next video. Bye-bye.